Hello dear students, myself Ganga Bhosle, your statistics teacher. Today we are going to learn F-test for two variances. F-test is concerned with two variances derived from two samples. Unlike in T-test we have emphasis on mean, and in F-test we take variance of population and check whether the two data series are from the normal population with a same standard deviation or otherwise. For this we solve example. It is always claimed that the girls are more intelligent than the boys. A teacher produced data of recent examination conducted. The percentage of marks of 15 girls and boys students randomly taken from the declaration of the result of a class. Comment on the claim generally made at 5% level of significance regarding intelligence between genders. Here given percentage of girl students, and in second row percentage of boys students are given. For this solution of this example, we write here first percentage of girl students in second column, percentage of boys students in third column. Okay. First we have to find out their average standard deviation, and after this standard deviation we have to calculate sigma 1 square, sigma 2 square, and after this we have to use the formula F is equal to sigma 2 square divided by sigma 1 square. Okay. First we find out average, that is sum of all these values. This is 75.66667 and average of this column is 64.66667. 64.667, that is sum of all these is 1153 and number of observations are 15. When we divide 1153 by 15 we get here 75.6667 and sum of all these values are 970, and when we divide 970 by n, that is 15, we get 64.6667. Then we have to calculate standard deviation. For this standard deviation we have to prepare table, that is for this we consider first this is our x1, then x1 minus x1 bar, x1 minus x1 bar, and here x1 minus x1 bar its square, then here x2 minus x2 bar and x2 minus x2 bar its square. For 69, here x1 bar, that is 75.6667. when we subtract 69 from 75.6667 we get minus 6.67, and when we square this number, that is minus 6.67, that is minus 6.67 square is 44.49. Likely calculate all these values. Then for x2, that is 53. Here x2 bar is 64.6667, that is x2 minus x2 bar, that is 53 minus 64.6667 we get minus 11.666, and when we square minus 11.666 we get 136.095. Likely calculate all these values. Then we have to find out standard deviation, that is sigma 1 and sigma 2. For this sigma 1, which is equal to, we have to divide first, just a minute, first we have to sum of all these x1 minus x1 bar, and summation x1 minus x1 bar its square is 643.2053, and summation of x2 minus x2 bar square is 653.330116. That is sum of all these values 136.095 up to 28.4515. Addition of all these values is 653.330116. Then first we find out sigma 1 and sigma 2. That is sigma 1 is equal to under root summation x1 minus x1 bar square divided by n minus 1, which is equal to under root 643.2053 divided by 14 is equal to, when we divide 643.2053 by 14, we get 45.94, and the square root value of 45.94 is 6.778819. That is standard deviation, which is equal to sigma 1 is 6.778819. Similarly, we find out sigma 2. That is sigma 2 is equal to summation x2 minus x2 bar its square divided by n minus 1 is equal to sum of x2 minus x2 bar its square is 653.330116 divided by n minus 1, that is 14. When we divide 653.330116 by 14, we get 46.667, and the square root value of 46.667 is 6.8312. So we get standard deviation which is equal to sigma 2 is equal to 6.8312. Then sigma 1 square and sigma 2 square. Sigma 1 square, that is 6.778819, its square is 49.25, and sigma 2 square, which is equal to 49.98. Then we write f is equal to sigma 2 square divided by sigma 1 square, which is equal to 49.98 divided by 49.25, which is equal to, here we get 1.01. That is, when we divide 49.98 by 49.25, we get 1.01. Here we have taken the value of sigma 2 in the numerator and the value of sigma 1 at the denominator. This is to ensure that the calculated f should be more than 1. Now we calculated table value of f, that is f statistics is 1.01. Then we have to find out in table value for degrees of freedom, that is n minus 1 is equal to 15 minus 1 is equal to 14. That is 14 degrees of freedom at numerator and 14 degrees of freedom at the denominator. Just a minute. This is our F distribution table. Then we have to find out here 14 degrees of numerator and 14 degrees of denominator. 14 degrees of freedom at numerator and 14 degrees of freedom at the denominator. This is our 14 degrees of freedom at numerator, and this one is 14 degrees of freedom at denominator. So here we get 2.48. 2.48. Table value of F at 14 degrees of freedom at numerator and 14 degrees of freedom at denominator. Denominator is, what is the value of table value? 2.48. 2.48. Hence, it is concluded that the calculated value of F, that is 1.01, is smaller than the table value of F. So, the null hypothesis is accepted and the alternative hypothesis is rejected. Null hypothesis is, here null hypothesis rejected and accepted, and alternative hypothesis will be rejected, and alternative hypothesis is rejected. In SIM on page number 190, the value is, that is table value is 3.66 is type, but this is 2.48. Okay. So from this, when we accept null hypothesis and reject alternative hypothesis, so it means that the percentage of girls and boys students are drawn from the same population. Okay. I hope all of you understood this example. Thank you.